Hi everyone, welcome back to another Julia language tutorial. We are working on our image puzzle game, and last time we've created the basic interaction between our player and the game. So we're doing great, and today we need to write the exact logic to make the swaps of the blocks. Okay, let's go to our code, and just to remind you, we have the signal connect to tell us when the window is destroyed and we can kill the game, and the second mapping of the signal of the button press signal to indicate us that the player has interacted with the image and we need to do some stuff with it. So for now we have our position is we converted it from the XY position to a floating point sub-pixel accuracy, and we need to translate those sub-pixel points to the block which we pressed inside. So I will write a helper function for this, and we can just define the function as get block chords. So actually we want to given coordinates and the block size, we want to return the margins of the block. So maybe I'll even add some documentation. So get the margins of the block from XY pixel location. So I recommend you to always, if you can, define what are the type of the variable. It will make Julia run faster, as you know. So this is a tuple of two coordinates, so each one is an abstract float. Again, abstract so each is an abstract float. It's the super type of all floating point numbers. So float 64 is one concrete type of this one, and the block size is also a tuple of integers. Yeah, and what we need to do is we need to calculate where in the block we've pressed. So in Julia we can make divisions like this, and this will get us the exact division. Div will get us the integer for this division. So in this case it will be 1, and the reminder is the reminder of the division. So it will be 2. If you remember division basic divisions learned in school. So I'm using the reminder method here. You can to calculate the offset, I'll use the reminder. You can do the same manipulation also with the div. Now easier for me to cast both coordinates to the block size and get the offset in the block. So this is the offset, and from the offset we can calculate that the top is at chord. Let's begin with the left actually. So left is equal to chord in the first position minus the offset, the first position, plus 1 due to the Julia type indexing. And for the top we can use just the same, only with position 2 for both of them. And for the right margin is the left plus block size at position 1, and minus 1 again to so the right will be the exact multiplication of the block size, and the bottom is top just the same. And now we just want to make sure we're always working with integers. So due to the chords is some kind of floating point, and I want it to be returned as integers, so I'll define something like this for an array or tuple of left, top, right, bottom. Excellent. And I'll return so we have our translation from subpixel coordinates to the block, and now we can use it. So let's define here the margins to be equal to running our function with row and column, and running them with the block size. And as we define it here, we understand that block size is actually not known in the scope of the main function. So global size is defined in the init game function, and its scope is only the local scope of this function. To create it a global scope, meaning for all the module, I can define the global keyword for block size. And it doesn't really matter where you define this global. You can define it after the first user. It's not really matter, because the Julia compilation just understands that this should be a global variable for this module. So we have our block size here, and now we can actually annotate. Now we can actually annotate for these values. So if you remember, to annotate, we give the GUI dict, and we can specify which type of annotation. Annotation box. So annotation box is a box, as it sounds like, and we need to give it the position of the box. So I think, yeah, so margins in place 1, and I can paste it 3 times. So margin in left, top, right, and bottom. And we can continue here to specify the line width of the box, which would be 2.5, and the color should be colorant blue. Yeah, so I think this is fine. And so to actually annotate this, we need to change this value to be true. So we will activate the first click logic in code, and let's see what we have. So GUI dict is equal to main, and yeah, you can see we already highlighted the 0, 0 block because we have an initial value. So we'll deal with this in a second. And as I click another block, you can see I'm highlighting more and more blocks. Yeah, very nice, very information. Yeah, I can close the window now. So a few more things we need to do. So we talked about the init value. So I don't want the logic to run for the initial value. So we can add the mapping to have an initial value. And let's say the initial value would be 0 and 0. So it's a floating number 0. And what else do we need to do? yeah, we need to, now we would want to create the swaps, and for that, let's just say we'll need it. I'll understand in a second. I'll actually assign the annotation handler to some variable, and I assign it to the annotation handler. And let's write a helper function for the swaps. So again, we are writing swap blocks, and it should be given a box A, box B, and the image. And let's just define it, so it will be, so box is an integers of left, top, right, and bottom. So this is what I expect, and I want to swap the blocks. So if you want to swap two blocks, you can't do it in place. You have to preserve some of the data in a temporary array, because unless it will be deleted as you override the image. So I'll just define a temporary variable, temp array, which is box into box A in position 2 to box A in position 4. Just to remind you, as I said, this is actually the rows from top to bottom, and now the columns is box A1 to box A in position 3. And I'll copy this as I will use it in a second. Now I can swap the image in A should be equal to the image in the B position, so this should be replaced with a B. Also this should be replaced with a B, and this and this, and I can copy in this entire row. And now the B position is actually equal to temp, and we can return the image. Yeah, so the swap is I'm taking A to be in the temp, and then B in A, and then temp into B. So pretty simple. And now we can actually define the swaps. So swap the blocks of margins, and the previous margins, which is the previous boxes, margins, and the new image. But as we can see, we don't have previous margins. So another thing you need to understand that each time we click the button, we run the function again. So it's a different namespace for the function, and to avoid this, we need to define another global variable which will live between call and call to the function. So I'll define the annotation handler as a global variable, and as I define annotation handler, I also need to define the first click also as global. So this actually will live in the first call will activate the first click clause of the code, and we'll get the annotation handler. And for the second time, we'll have the annotation handler, and we can use it here. So I'll define the previous margins to be actually from the annotation handler. So it will be the annotation handler and data and left. This is basically the left position. It's saved in a floating point number, so I'm using the integer casting again, and now I just need to arrange it a bit to be the left, the top, the right, and the bottom. And for the swap locks, it's okay. But what we can see, we need to actually traverse between first click, second click, first click, second click. So let's add here something like first click is now false. And after swapping, we can add first click is now true. We can also delete the annotation, so we don't carry on too many annotation. Yeah, this looks fine. So just let me look at the code. We have the previous margin and we have the integer. Yeah, one thing I want to add is guarded keyword, guarded macro. As you develop, sometimes you can mess up the inner state of the GDK, and to avoid it, you should use try and catch. So the guarded is just that. It's part of the GDK package, and it should do just that. It wraps every function call to that try and catch, and it doesn't always work for me, but sometimes it saves you from refreshing the session of the Julia. So yeah, let's hope it will do the trick for us. So we have the margins, and I don't think it looks okay, and this one's okay. Yeah, so let's try and run it. So okay, so we have highlighted one block, and now we can swap it, and yeah, it seems nice. It seems it works for us. We can arrange the image, and yeah, looks good, right? You can set the neck in the correct position, and you can finish the game if you have time for this. So I hope you enjoyed this episode. Next time we will work a bit on some performance tips and maybe how to end the game, so we will know when we have finished the puzzle. Hope you enjoyed. Please comment below. Let me know what you think, your likes, your dislikes, and don't forget to subscribe. See you again next time. Thank you very much.